Yeah, good afternoon to all of you. Today we are going to develop one particular program. That program is this one. The program could be so ls-l. ls-l command is going to develop by us today. So as far as the previous command, so that is copy command, I have identified two mistakes. So let me explain those mistakes first, and we'll move to ls-l. The mistakes are, let me open the file. Yeah, UP class lab. So the problem as raised here is, I thought that normally in Turbo C, that is Microsoft operating system based C, if you are supposed to open your file in W mode, obviously the file will be gets created. So that is the point I have observed from that particular Microsoft C. But here it is Unix based C. There are two different types of system calls to create and to open. We have forgotten to create the file while copying. We have forgotten to create the file. So that is the basic mistake which we did over there here. So if source is not available, then destination must be. So open something like this. After opening this one, we'd like to check that whether file is existed or not. What is the destination file is? Second parameter is existed or not. So if it is existed, then we'll continue based on the user's response, that is yes or no. If it is not existed, so this statement was missed. That is the point I would like to correct here. The destination must be equal to, so it must be created. Create argument vector 2, whatever the second parameter you have given as the file name. So s underscore iwusr. Okay. Otherwise, you could also place s underscore ir usr for user. You could give read and write permissions. There is no problem. Then we have to copy. Then we have to copy the contents. Okay. Then of course it is our message which we are interested to display this one. If a file is does existed, what exactly if user wants to do that one, first of all we need to close the file because it is already opened. Here it is already open. We have to close that particular file first, and then destination must be created one more time. If you create one more time, obviously previous contents will be overwritten. Overwritten in the sense so everything will be wiped up, and it could be create a new file with the same name, and then you have to copy everything here. So that is the point where exactly we have missed in the previous session, and this is the complete program which could be used to evaluate or execute copy operation in terms of CP, which is being implemented by us. So let me show you. For a while, let me show you. Okay, look at this. CD UP class, CD lab, and GCC COPY.C-O COPY. Okay, of course, don't bother about this read and so write operations and close operations. These are system calls, so that there is no problem. You don't worry about these warnings. Then so ls, we do have two files here. EAA, the file pq is there, and the pqr.txt is there, xyz.txt is there. Let us do something like this. So /copy followed by let me take, before going to take this one, so cat pq, what is the content of the pq? So this is the data which is available. Now /copy followed by pq is the first parameter. Second one is some bbb, whatever it may be, whatever the name it may be, which is not existed actually. Okay, look at this. Copying is completed. Then you will go ahead with ls. Yes, you could identify the new name. Previously it doesn't exist. Now it has been existed. Okay, it has been created. And secondly, if you are supposed to operate, second is something like this. that is so PQ2 AAA, the file AAA is already existed. So AAA could be already existed. Let me consider file does existed. Do you want to continue? Say yes or no. Yes, I would like to say yes. So copying is completed. Then you will go ahead and look into so that particular file. Yes, AA is already there, and the file which is available that could be overwritten. Okay, so CAT AAA. Okay, CAT. So triple A. The file name is triple A. Yes, whatever the content PQ content will be, so overwritten by the previous content. Okay. So this is the complete program, which is useful to you to put in our laboratory session, laboratory book. Okay. Now come to this area, ls-l. Normally we know ls-l could be gets operated something like this. If you take, sorry, so ls-l will be taken by you. It could be able to display. So the permissions first, followed by so owner, and followed by the administrator, followed by owner and the size of the file, and then when it was created, and then finally the file name. So let us consider, we are interested to display these permissions first, followed by ID value, not exactly the name, ID value of your owner will be displayed, then size of the file, then file name. Only these three will be gets displayed. Permissions, number one, permissions. Number two, owner name, owner ID value, then followed by size of that particular file, then followed by file name. So we are expected to display only these values. Today's session is very small session because already I have created the program. So I'm unable to write in front of you at this moment because the file is very difficult to write, so that it is already created. Let me show you. Let me show you. Yes, it is. Right. Okay. lis.c. Yes, you could see this one. Okay. So very important of structures we have to consider here. So number one structure is which is used to open the directory. This particular structure is used to open the directory. So whether it is visible to you or not, let me know first. Will it be visible? Otherwise, I will increase the size. I will increase the size of already it is with 18. Let me go ahead with 20, 21, 22. Up to 22, I will go ahead and I will display. Okay. Okay. Look at this. Look at this. So here, so we are expected to take two different types of structures. One is direct ENT to open the directory, and then second one is file statistics. After opening your directory, you may be pick up 1111 file, and we need to check out those file statistics. Okay, file statistics means permissions of the file and size of the file and who is the owner and all those. All those things are supposed to be taken from this particular STAT. This STAT was defined in so hash include stat.h. Okay, hash include stat.h. It has been defined, and this directory, this dirent has been defined with dirent.h. It has been defined within that particular thing. And here, first of all, we would like to check out the environment variable here. Environment variable in the sense, look at this. So export, if you go ahead and apply this particular export will be gives you complete information regarding to your environment. So out of this, one specific item is, so look at this home. Home is what is the home of this particular user, and followed by present working directory. Okay, PWD, present working directory. We are trying to get the value of this present working directory from the environment. Okay, from the environment. We are trying to get this particular present working directory here. So this present working directory will be taken by this one, I think, by, so get env. Current directory will be equal to get env of that particular present working directory, whatever the present working directory which we have with us. So we do have a present working directory as slash home slash copy slash up class and slash lab. This is the total string which is available with us. So this string will be going to store at so current directory. Look at this. This current directory is a character, pointer. Okay, that value is going to be stored somewhere else. Why you have taken character pointer here? In the sense, we don't know what is the size of that present working directory. So that is why you are unable to define an array with some set of structure. It is not possible to display with that particular structure. So that we would like to take this as a pointer here. If this is null, so present working directory's value could not be there, then obviously you will come out from the program because no directory is there, so that you are unable to display anything here. Okay, then followed by, if present working directory will be taken into consideration, and there you need to check the directory name. The directory name is, as far as present working directory here, you could consider here lab is the present working directory. This is actually path, and the last one final value will be present working directory. That lab is going to be taken. Lab is going to be taken by, so this particular where it is. So open directory. We have to open that particular lab directory as far as PWD which is being available with us. If it is also null, if it is unable to open that one, again you have to print some error message and you will come out. You will come out. So these are the 2 points which we have to consider. Point number 1 will be, you need to get the information from the environment, stated that what is the present working directory. If present working directory could not be there, PWD will be gives you null. Nothing has been available here. So here everything will be null. Nothing is there here in the export. Then obviously, so we would like to come out from the program. We are not supposed to display anything. If present working directory will be there and the directory will be available, then that could be open with the directory, open directory. So that directory is going to be open. If it is open or not, it is going to check that. If it is not unable to open, then DP will be having null. If it could be open, some pointer will be there. So if DP will be equal to null again, then obviously will be come out. Okay, nothing has to do. These are the 2 different types of test cases which we'd like to perform. So before going to display the contents, then followed by next operation is, if present working directory is there with us and directory also be gets opened. Directory also be gets opened. Now what you are supposed to do? You are supposed to do fetch each and every file from the present working directory. In the present working directory, you have to read file by file, file by file, file by file, and so on and so forth. So look at this. Directory pointer will be equal to read directory of DP, where DP will be the directory name. Okay, the directory name. Within that particular directory, we have to read 111 file. Okay. Until what extent you are supposed to process here, in the sense, you have to process until the data which is goes to null. Okay, so for example, now present working directory will be this one here. This is the PWD is this one. So here, if you go ahead with the ls, look at this 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 files are there here. First, this file will be taken and display everything. Second, this file, so it could not be equal to null. File has been read from the directory, so that could not be gives you null. So that it could be displayed, and so on, up to 20 times the data will be so fetched from the present working directory. And if you are supposed to operate the same command, for the 21st time, so 21st time there is no data. I mean, one more file is not available. So since it is not available, it could be displaced null. Null not equal to null will be false, and for loop will be gets over. Okay. Now, what exactly we are trying to do? You have to take, so here, so dpr dot, so dname in the sense, whatever the file name, that is the structure actually, that structure has taken as a d underscore name as the one of the parameters to get the file name. And after getting this one, you have to store your statistics in this particular filestat. Look at this. Filestat has been defined as a structure. Okay, so complete status will be, statistics will be gets stored into filestat. So out of this, st underscore mode already, this was discussed by us in the previous class. Actually, we have discussed this one in the previous class. Look at this at the end. Last and final thing will be, last and final thing will be, so this one only. You could say structure stat here and here. So st underscore uid, st underscore limps, st underscore mode, st underscore gid, group id. So reverse id, I mean device id, and st underscore size and block size, number of blocks. Everything has been discussed in the previous class. Okay. So that particular, that mode will be equal to s underscore ir user. What does it means? So it is per user read permission will be there or not. If it is okay, then we have to display it. Otherwise, we have to display hyphen. Okay, it is actually ternary operator. It is actually ternary operator. So ternary operator will be taken. So condition question mark value if written true, colon value if written false. So that ternary operator this one is. So we have to check that whether this could be there. If it is true, then display on. If it is not true, obviously we have to display so hyphen, and so on and so forth. Everything will be checked here. So WUSR, XUSR, all these things also be discussed by us in the previous class. So I hope that somewhere, yeah, not this one, yes, here itself. We have discussed everything in the previous class. Look at this, IR, S underscore IR WXU. So that is per user RWX will be allocated. So I read IR user. So IR IWRIT. So IW USR. Same thing we have been used to check out here. Same thing we have been checked out here. For user RWX, for group so RWX, for others RWX. And finally, this one is it a directory? That is what we are trying to say, check about this one. ISDIR, whether this is a directory or not. If it is directory, then display it as a D, otherwise hyphen. If it is not a directory, so this one here. Then followed by what is the user ID of that particular file. Then what is the size of that particular file. And finally, the file name. Okay, already I told you. So we are trying to display the permissions of that particular file and user ID of that particular file, size of the file, and then so directory name. And finally, it is our special interest to display how many number of files have been so listed out here. So everything will be displayed here. This is the specific program which is useful to you to list out ls-l here. Okay, let me execute this one for a while, then you will see it. Look at this. So gcc lis dot c -o lis. Yes, everything is executed successfully. So now dot slash lis. So these are the specifications which we have to display here. So first one, and the group ID, I mean user ID is 1000. Size of that particular file will be so 8592 bytes, and the file name is analyst. Okay, and so on and so on. So like this, you have your own information which is going to display. So totally, so 23 files. Why it could become as 23 files in the sense dot and double dot. These are two extra hidden directories will be there for every directory, not exactly this one. For every directory, automatically it could be taken. So dot in the sense present directory, double dot in the sense it's a parent. It's parent in the sense. So in PWD, for example, if you take, so I am working with a lab here. So to identify lab, you may be specified dot. To identify its parent, you may be specified double dot. Double dot will be UP class. dot will be lab. If you are at UP class, for example, if you are at UP class, then dot will be UP class, parent will be Gopi. If you are at Gopi, so dot will be Gopi and parent will be home. If you are at home, so dot will be home and parent will be root. If you are at root, so dot will be root and double dot, there is no parent for double dot could not be there for root. Okay. In this way, so you could identify. So these also be, these are actually hidden items. So these hidden items also be gets displayed here. So in this way, it could be displayed this particular data. So I'd like to so post this particular file and total code, entire code to you in the Google Classrooms. You please go through. You please go through one time. So this is what about the information regarding to your complete LSI for you. Okay, so you have to write this particular code completely in your book, and output will be gets displayed out there. That's all. So this is what about the class today, and tomorrow we'll take this particular command, and as of now we'd like to stop our work with the laboratory, and we'll continue with the class with the 6th unit. After completion of 6th unit, we'll come back to so 5th, 6th, 7th, and 8th so programs also. Okay, so this is the agenda we would like to consider here. So tomorrow, so we'll finish off this particular class, this particular program, ls-l, so followed by pipe sort. Okay, sort operation could be gets operated out there. How these two could be gets operated. So let us have a discussion by tomorrow's class. Okay, thank you. I'll post. I'll post immediately. You please go through that particular program and note down somewhere else in our what is that notes, and you have to keep it up.